सा फायर नहीं बचता है. So try to understand my point that if there will be a fuel, there will be an oxygen and there will be heat. This is what generates fire. इसमें से एक भी चीज को हटा देंगे, फॉर एग्जाम्पल ऑक्सीजन इफ वी रिमूव, तो फायर नहीं रह जाएगा. फ्यूल हीट रिमूव कर देंगे तो फायर नहीं रह जाएगा. सो इट्स अ रैपिड ऑक्सीडेशन ऑफ अ मटेरियल in the exothermic chemical process of burning, releasing heat, light, and various reaction products. So that's why you might have seen so many fire resistive materials also, fire extinguisher also, which give you byproduct ki oxygen we are decreasing, maybe carbon dioxide we are increasing just to resist out that fire for the particular time lag, which we'll be seeing in the next slides. Next, please. Okay, now we have categorized fire into the typology, that's A, B, C, D, and E. It's been rated into different colors. This is a fire safety set basically. So if we move on to the next slide, it says that class A fire. Class A fire involves solid materials like wood, paper, or textile. So, whenever you are talking about fire, it means in the A class, this is being decoded with red color and it's involving the solid materials. So, they're being categorized into categories B, C, D, where you will see the combustible and non-combustible materials separately, and where you will be seeing that through gases there are different type of fire being categorized into A, B, C, D, E. Through solid materials, it's been categorized into A class. So extinguishing medium when we talk about class A is water, and when and fire safety, it's just not about its codes and regulation. It's about foresight, innovation, and commitment to protecting human life. So when we talk about human life protection, when we talk about designing spaces, we have to categorize those things into these A, B, C, D, E groups so that we can understand that what material is combustible and what material is non-combustible, and which material adheres which problem in terms of making this design solutions and innovations, right? So moving on to the next slide, we see that class B is of involving flammable liquids like petrol, diesel, or oils. So this extinguishing medium says from CO2 DCP, dry chemical portable extinguisher. So when you see this dry portable extinguisher, what do you understand by this? It's a type of fire extinguisher basically, guys, that uses a fine powder basically as an extinguishing agent. As you can see that the extinguishing medium is either its form carbon dioxide, DCP, dry chemical portable extinguisher. The powder, what they are doing in this, what actually the process is, the powder is typically pressurized with nitrogen, or it's been compressed into air, and it's been designed to combat a variety of fire types. Key features of dry chemical extinguisher, or maybe you can say the extinguishing agent, where the powder is usually made of mono ammonium phosphate. So these are some chemical aided words which are used for doing the safety. So when we talk about class B, it's the liquids or the flames by petrol or diesel or oils. So how to combat them? We have to combat them by the extinguishing medium of dry chemical portable extinguisher. So if we talk about class A, B, C, these classes are being come under this dry chemical portable extinguishers. Fire involving ordinary combustible like material, if you say wood, or if you can say paper and fabric, it also comes in the same. B section cause flammable liquids like petrol, oil, or grease. C involving any electrical equipment. Electrical equipment, say if you are getting some fire, it's comes in that. So these are some examples of how where we can use these DCPs. Next, please. Next.
Yes, ma'am. I've moved the slide, but
But actually, it's on the previous slide. So we could next one.
just a second, ma'am. I'll just reshare the
Sure,
screen.
sure. Mhm.
Is it visible now, ma'am?
Visible, but it's on the class C only. Okay. Yeah. Class C is basically involving the gases. So, out of gases, when we are catching fire, this comes in class C, and the extinguishing medium for B and C is dry only, DCP, or maybe the carbon dioxide or water. So, there are certain cases where water is not needed. There are certain cases where DCP would not work, and there are certain cases where carbon dioxide would not work. What actually this carbon dioxide is doing, we have studied in the previous slide, in the first slide, कि oxygen से we are getting fire, है ना? Oxygen है, heat है, तो इन सब चीजों से we are getting the fire, all those three processes. So when we are increasing this volume of carbon dioxide, when we are pressurizing this, so our oxygen gets lower and हमारा fire gets lower. So this is the basic and a simple process that we have to understand कि where we are categorizing our fire from through that particular type of material, and how we are extinguishing, giving that the extinguishing medium. I hope you people are relating this towards the material approach, and towards you will be relating it with the open spaces and maybe the combined spaces and the enclosure spaces approach also, which we'll be seeing in the next slides. Om, can you please go on to next? Class D. When we talk about class D, fire involving metals like aluminium, magnesium, copper, etc. So what will be the extinguishing medium? It will be again DCP, sand, dry soil, limestone, ash. So you just try to relate this thing with the framework. So wherever we are using the framework of steel, or maybe the aluminium, or maybe the copper or something like that. So I'm relating it to the building technology type of things, building material type of things in form of our design solutions which we give. So you people might be very much aware about the framework of wood, and the framework of aluminium, and the framework of this prefabricated material also. So, over the period of time, we got to know that wood catches fire very much easily, right? So this being researched, that again these aluminium or the metals can be incorporated in our framework so that they cannot catch the fire, they can give that type of time lag. तो अगर मैं वुड की बात करती हूँ तो वो मे बी 6 इंचेस में या हाफ इंचेस में, हाफ to 6 इंचेस में 15 मिनट में, it has a just a time lag of 15 minutes. 15 minutes में it catches a fire. If we talk about this aluminium and the metals, we need to do some type of coatings in it. So it comes in class D, and we have a medium for this, a specified medium कि हम dry चीजों से we can sort it out this situation. Basic is that do not use water in this type of fire. So when we are talking any material which falls into class D and that is giving the fire according to this category of class D, we have to be very much cautious about water. We are not allowed to uh, use water in these type of metals. Next, please. Next is our class E. Live electrical apparatus technically doesn't exist. This is used for convenience only. So it's basically when through electrical appliances and all these, the you catches fire, you catches the shocks and all. So this class relates to that. So for this, you are basically advised to first cut off the main service line, main lane. This is what most advisable point here is. Now, when we talk about all these categories, these are all associated with the understanding of different type of formation of these fire, how we catch a fire in a building. So to conclude, understanding the categorization of fire from class A to class C, it's not just basically a theoretical exercise, guys. It's a practical necessity to understand for anyone that involved in the field of architecture or design. Each class is basically representing a different and a unique type of risk, and each class is requiring specific prevention that you have been seeing from A to E, and suppression strategies. So, as an architect, incorporating this knowledge into our design ensures that we create spaces that are not only functional and aesthetically pleasing. So, when we are just moving on to spaces, we are advised that you need to give some fire escapes, right? Everybody is, I think, architecture background student and design background student. So, you might have been, known with this fact that you are given this fire escape routes with certain duration. So this is all being due to the fire safety per lances we judge all this thing. Okay, next slide, please. Hmm. So now just you see at the slide where we have this heat, fuel, oxygen, again 3 points. And correlating these 3 points, we have different extinguishing methods. So in cooling, we are basically doing by water, again categorizing from where we are getting the fire, then we are using that type of method. So we have cooling, smoothing, and starvation method. So the cooling is completely extinguishing method done by water, smoothing extinguishing fire by foam. So wherever foam is being required, it's being done by that. Starvation, fire by removing burning components, where we are basically removing the burning component. Entire component, maybe oxygen we are reducing, maybe fuel we are entirely reducing by sand or something like that you have seen on petrol pumps and everywhere. Or maybe heat we are reducing by using certain amount of materials or certain amount of fire resistant materials. So it's completely dependent upon the category. Next. Okay, these are some basic understanding where you people can see the causes of fire. So the causes of fire is what we have basically percented out in terms of these 4 to 5 things, in terms of these 5 cases. So the first one is cooking. From cooking, we usually get 49%. Like the fire is being, this is a relatable thing, the cooking. Open flame. What you understand by open flame is, it's like, example I can give you, open flames, it's in the picture also, candles, gas stoves and burners, Bunsen burners, campfires, welding torches. And what can be the fire safety concerns? So the fire safety concern in open flames can quickly ignite flammable materials, jessica, paper, fabric, gases leading to uncontrolled fire. So these open flames are directly related to the concerns which are paper also, fabric also, and gases also. Now you can easily relate these all the percentage to different type of categories, and you can easily make out ki which type of extinguisher can be implanted to improve this thing, to basically safeguard yourself, right? Then it is heating. From heating, it's 9%, and then then it's incendiary or arson, it's 8%. What do you understand by incendiary? It's something like if you see bombs used in warfare. Okay, so there are certain cases where the fire through bombs are also there. So this is that type of percentage which we have given. Now the fire safety concerns or the threats are very critical in this case. So buildings are basically equipped with, when we talk about this incendiary or arson type of materials or type of spaces we design, fire resistant materials to minimize damage. So here we can use detection system. Like I'll tell you one thing. Like for example, if a space is basically or maybe a building which is used in warfare, in times of warfare, it's completely of that, and where bombs and all these shell structures are made just to protect the people, protect the army. So there we need to incorporate our fire safety systems also. So for that we need detection system, which are very much into the market these days, to identify key what can be the attempts in the future, or what were the attempts early also. And fire suppression systems are also very much important here. When we are implanting the strategic placement of suppression systems, it's very much required in these types of fires. Next is our smoking. This is almost 4%, and this is also very much harmful. You are basically here to understand that which type of fire is caused by which type of action, and then it is being categorized in which category, and then that category falls into which extinguishing portion, and understanding the material and understanding the spaces. Next. Now, important safety elements are alarms these days, very important, fire extinguishers, residential fire sprinkler systems, which are, you all might have seen, maybe people who are in second, third years in housing projects, in the commercial projects, in the small scale or the large scale projects, that this fire sprinkler systems being the very much important part of the services these days. Next. So when we talk about this alarm placement and maintenance, so you need to make sure that you can hear the alarm from everywhere. Because when we are talking about this safety purpose, it is very much required that the detectors has to be very much sensorized. And again, the detectors need to be hearable. What type of detector you're being using. So when you see the picture being on the left, we are able to see that smoke alarms on every level is required, in each sleeping room, outside the sleeping area, wherever it can be, it is required, right? They should be loud enough to wake up from sleep. So it's very generic, so you need to understand that these the importance of alarm placements and how you can maintain them, and what all sensory objects you have applied. So that is very much open into the market. You can understand their route, and you can learn types of alarms, and what type of sensory items they've been using for these fire detection alarms. Next. So we are here to tell you that there are different type of fire extinguishers also, to control small fires, to control emergency situations, to make this, if the situation is out of control also. So what can be done in that situation? So depends upon the fire extinguisher. So there are different typology in the extinguisher also, depending upon how is the cause of fire is. So there is one type that is called water, foam, gas, powder type, being categorized into the into the A, B, C, D, E categories, where we have learned that what are the causes of the fire and how we can prevent ourselves from that type of fire. Next, please. Okay, so if you see this whole uh, slide, you find that first one, water type, is basically good for the cause of solids, wood, paper, clothes, etc. So wherever the fire is being caused by these three to four things, it's best, the water extinguisher type. Now, if we move to foam type, then it's good for solid also. It's good for flammable liquid also, and for cooking oils and fats also. So there are three causes which fits in this foam type. That is solid part, flammable liquid part, and the quick cooking oil and fats part. Moving on to the gas type one, it's important. It's very much important that gas one would deal with the solid wood, paper, clothes, etc. So these are basically the causes out of which the fire has been caused, and these are the extinguisher where we can use these things. So during flammable liquid also, it's can gas type can be used. Flammable gases also, electrical equipment, electrical shock, where you have come across the fire with shocks and all. Then it's cooking oil and fats, a big no-no. We cannot use this gas type fire extinguisher. The next is DPT, that is dry powder type, right? That cannot be used in solids. आप अगर paper से it's being caused fire, or would say it's a fire, so you cannot use this typology. Next is flammable liquid may you can use, then electrical equipment and cooking oil and fats. So again, this is a full picturization of the causes and the types of extinguishers being used in different types of categories being studied earlier. Right. Next, please. Fire resistant materials. So, guys, what do you understand by fire resistant materials? As we are the architects, need to and the designers need to understand the this chemistry behind fire resistant and the materials too. What is the time lag of the materials? There is a different time lag for different type of materials, and how we can resist it for ours, or what are the materials which we should not at all use. So I'll just give you one example of a maybe a roofing system. That is, we all are very much aware about the flat roof system and pitch roof system. So this is just a generic example so that you people can correlate. This is related to material also, and this is related to type of casting the slab also. So when we talk about our plain and flat slab system, we are very much considered, and we are very much known by this fact that for us, flat slab is the fire resistant approach towards making a slab. In terms of fire resistivity, this pitch roof doesn't work very much well. So if you've ever seen this furnace system, so the fire goes up and up and up and it rises up in this furnace system. So as the logic comes under this pitch roof system. This is what we basically come across with the problem of fire safety in terms of casting a slab. This was an example of a space and an enclosure. Now we'll be moving towards this material part. No building material is perfectly fireproof. It's very much important to understand कि we can just claim out that my building is 40% fire resistant, my building is 50% or 60 to 70% fire resistant, and I'm claiming on this fact on the terms of my the enclosure I have designed, or maybe the materials I have used. So for example, if I've used the entire frame system, or maybe the false ceiling system with all asbestos and maybe different type of materials, so the time lag is 2 hours. That's why my building may be 40% into this fire safety zone and fire resistivity zone. So every building contains some materials like furniture, clothing, edibles, etc. We have everything, which every category we have, guys, in our building, category A, B, C, D, E. So we have to be very much cautious while designing, while placing the material, while selecting the material for the our internal finishes, for our external finishes, for our framework, for the external framework, and for the design we have done in our interiors, right? Which can either easily catch fire or which are vulnerable to fire. So vulnerable to fire is something which is very much easy to catch on with. Like, so the things which fall on category A are very much easy to catch fire. So we need to make ourselves understand and make our client understand also that the framework or maybe the enclosure which we are designing is require this type of material, right? A wider interpretation of fire safety may be deemed to cover the following aspects: fire prevention and reduction of number of outbreaks of fire. I'll let you know what they're saying. Spread of fire both internally and externally. So when they're saying the reduction of number of outbreaks of fire, it's they're talking about the enclosure you have given. So let me just make you understand with a very simple example that we people, when designing a building, are advised and designing a maybe a high rise building are advised to give less enclosures in terms of windows, right? But again, when we are talking in terms of design terminology, then we are very much into this fenestration, ventilation word. Our teacher, our mentors, our designers are very much into this. But again, fire safety has some ratio. So if the building height is 30 meters or 25 meters or 60 meters tall, then your fenestration ratio has to be according to that building. This is being coded in National Building Code and being saved as a fire safety norm. So this is what they're saying is that number of outbreaks is very much important, going rising high or going horizontally or vertically. Next is spread of fire both internally and externally. So spreading of fire is again bounded towards the material, whatever you are using at the external finish or the internal. Just give you an example of RCC. So we are very much aware about this coating of RCC, and column को cast करके RCC casting करते हैं, and we design the things according to this. So if you don't know, then I'll let you know that RCC is also a एक हद तक वो फायर रेजिस्टिव मटेरियल है, ठीक है. Thereafter, we also do some certain type of coatings to make it fire resistive material. But at a certain point of time, there are different type of materials which are combustible and non-combustible. We'll see in the another slide also ki what are combustible materials. The materials basically which catches fire but which have the capacity of resisting it for certain duration of time, which can destroy the material but it can withstand for a duration of time. And again, non-combustible, which are very much vulnerable and which don't have that withstanding power, right? Safe exit of any and all occupants in the event of an outbreak of fire and fire extinguishing apparatus. So when they are saying safe exit of any all occupants, I'll give you one more example. That is when we design, maybe you people are very much aware about the corridors and the corridors width. So you are advised to give the exit point, the width of the exit point should be same as that of the corridor. Right. So आप जिस corridor से wherever you are passing through. So if it is 2.4 meters, so you're advised that the door should has to be that much width. Right. The width can be more, but the width cannot be less. Otherwise, you'll be ending up with a situation where people will not be able to move out of that area to take exit of that area. So need to design those outbreaks in that manner. And again, most important thing that is our extinguishing apparatus, which are maybe in form of fire extinguishers, maybe in the form of detectors, smoke detectors, fire detectors that are very much they're basically playing the major role these days. And to make the smart and intelligent buildings, we are using these type of apparatuses in our buildings, and which is basically enhancing our fire safety rules, right? Moving on to the next, please. Yeah, they're saying that we have divided our building materials, which are of two types, that's combustible and non-combustible. So combustible materials, it's just not giving any growth to the spread of fire. So when we talk about our bricks, concrete, clay products, metal, glass, etc., so it's not it basically have a very high temperature after catching the fire, but it can be decomposed also, it can be damaged also, it can be destroyed also. But again, the growth or the spread of fire is not very much high. It has a certain limitation of that thing, right? So aap kabhi bhi, whenever you will be able to see these if brick catches a fire, concrete catches a fire, or any clay product catches a fire, it can be decomposed, right? It can be destructed, it can be distorted, but you will not say it is turned into something which is very much within minutes ki wo just gone. So these type of materials are said to be as non-combustible, and that's why these are all the construction materials. Now the performance of the materials is judged by basically analysis, what we call as in terms of bricks, maybe in terms of stone, or in terms of RCC, or different types of coatings what we are using, different types of prefabricated framework we are using, the fire resistive frameworks. So that is a different channel, that is a different target. Ki now how much my building performance is in terms of fire safety. But this is something generic, that if we talk about non-combustible material, this is brick, maybe stones, clay products. These all are some products which can be damaged and decomposed, but the fire is not very much, spreaded over it. Next is combustible materials. Combustible materials are those which during fire basically combines exothermically with oxygen. And when there is an oxygen, and when there is when there is a heat, and when there is all these three materials, that will result in something which goes into ashes, right? In evolution of lot of heat and giving rise to flame. So there are three things: flame, heat, and our oxygen. In say this is the basic channel which is just revolving round and around and making the flame high and high and high, right? Whereas when we were talking about the materials above, that is bricks, concrete, clay products, metal, glasses, we were not finding that type of oxygen or something like that which can give the heat, oxygen to give a heat and to a flame, right? Here we are having that type of situation. So these type of materials are easily burnable, they burn and also contribute to the growth of fire. And these materials include wood products, fireboard, strawboard, etc. So you people might have listened in the market that this is fire resistant. The wood is fire resistant up to 30%, up to 40%. Okay, this laminate is fire resistant. This company, Green Plywood, is selling the and claiming that it's 40%. That is basically the performance of that particular type of company, of that particular type of wood. So the wood is also categorized into two parts: softwood, hardwood, and they are also categorized into different performance in terms of fire safety and fire resistivity, right? So what actually is that we because we as an architect are using wood as a framework also, and as doors, windows, panel, everything we are using. So they are claiming basically ki the wood which was catching fire in 30 minutes or maybe in 1 hour, it's taking the time lag of 2 to 3 hours now. So this is what they're saying. Wood can never be completely a proper fire resistant product. It can never be 100%. No product can be a never be 100% fire resistive product. It is just the performance in terms of fire resistivity, in terms of percentage, which the companies are claiming these days, right? Next, please. Now we have certain resistant materials which we basically use in our construction sites and in our making our enclosures as basic materials. That's called as rock wool, gypsum board, asbestos cement, perlite boards, concrete, calcium silicate boards, treated lumber plywood. This all you have maybe studied. I'm not very much aware about it. If you don't know, you can anytime ask me these. Treated vegetable fire, fire retardant treated wood, cement render. So these are the materials what we are talking about, where we are also getting our cement, also getting our boards, gypsum boards. So you all have seen the gypsum boards in the partition and the false ceiling. If you have not seen, you can go through the same. That gypsum board is being completely used in false ceiling patterns and the partition patterns, and it has a fire resistive property to a certain percentage. Now, when we talk about this asbestos cement, I'm just giving you an example. What it used to be earlier, it's been banned in India now. Why? I'm sorry. Why it's been banned in India? Because it has, when the fire catches, it has some fumes which are not inhaled and which are injurious to health. So it's been banned. So in the slabs and in the casting of columns, in the casting of slabs, the asbestos sheet or asbestos material used to be, you know, uh, it was played onto the after casting the slab and columns, and it was considered to be as the fire resistive material. The performance was okay and it was good. The product was doing good. The only problem was the it was not a green material and it has certain healthy issues. There are certain materials which are not considered green in this also, but still we are using because again, we are limitized in terms of our fire safety and resistivity issues. So this is what I am trying to make you understand and make you know about these type of materials which are being used in the industry and which are very much relatable and which are day to day life's demand, that it is actually giving the performance, not 100% but it's in the process and it's having a good performance analysis. Next please. So the slide is just saying withstand fire is an integral member of structure for the desired period. So yes, so I'll tell you one thing, that when we talk about our building performance, it includes fire safety also. It includes our building economics also. It includes the ecology also. It includes the environmental factors also, assessment impacts also. So there are so many factors. When we are stick to this fire safety, we need to give our life cycle cost analysis, where we have to give that analysis in terms of our materials, in terms of this fire safety rule. See that maybe if I have designed a structure and the framework of the structure everywhere is just wood or maybe the aluminium, then the life cycle analysis, there is two different type of analysis for life cycle also: life cycle analysis in terms of decay and decomposition, and life cycle analysis of cost benefits also. So when we are talking about this decay decomposition in terms of any fire, in terms of aging, in terms of many more things, many components are there. So we have to give in that analysis that the products what we have used, the materials what we have used are fire resistant and they can withstand, according to this building, they can withstand for maybe 100 years, 20 years, 50 years. So whatever you are claiming, that has to be aligned towards that component. When we are talking about fire safety, has to be aligned towards fire safety only. The structural members like in walls, partition columns, floors, roofs are of non-combustible materials having fire endurance ratings at least equal to those specified by appropriate authorities. So we have a proper channel through this also, that like what we say for green, it's rating system. Again, for fire safety, there is a rating system for every product. If you're claiming that it's totally fire resistant building, then it has a different rating system where they rate you for the performance of your building in terms of fire safety as well. Fire resistant rating is a legal term utilized by model codes to regulate building construction. Its resistive rating of various materials in construction are established by laboratory tests. Obviously, that if you are claiming that it's been 30% and be withstanding for around 40 years in case of fire also, then you need to make an analysis. So in analysis, if we take a non-combustible material as in maybe stone, so we have to give the thickness of the stone and we have to give the performance analysis of that particular type of stone or granite which we are using in our building. Or if we're using wood or teak wood or whatever type of wood or aluminium, again, the performance analysis of that particular type of material is required, which you are claiming it as a life cycle analysis of that particular building. Specified in terms of hours, a material or assembly can be expected to withstand exposure to fire. So here what you have to give is this type of wood which we are using in our frames, what this type of panel what we are using in our frames are withstanding, can withstand 2 hours or maybe 3 hours for particular fire. If the fire causes, then it can withstand for 2 hours, right? For exterior walls, floors, roofs, or masonry or fire resistant material with the fire resistant rating of at least 2 hours. So they're asking you, the rating system is basically asking you for 2 hours. So the time lag you have to go with is 2 hours. So you have to calculate, you have to analyze that yes, my wood, my aluminium, my this type of metal what I am using, or my this type of combustible or non-combustible material, maybe my brick, my stone, my RCC is having a 2 hours time lag. So this is what is basically important in terms of rating system in our safety rules of fire. Yeah, can we move on to next? Okay. Now they're saying about fireproofing of construction materials. Let's just understand what is fireproofing. If we are talking about fireproofing, fire resistivity, we are being saying from, maybe I'm saying from last 5-10 minutes कि fireproof होना चाहिए, resistive होना चाहिए, कैसे होगा? So yes, we have some certain limitations of some certain products and materials where we will be able to understand कि ठीक है, this much of thickness is required for this type of material, right? So structural steel may be protected in a number of ways. It can be faced with brick, concrete, or tile. So if you know about the steel framework, or if we talk about the steel, so it gets heated easily. So it is important to get rid of that heat. So that's why it's been the layered is being formed in this type of framework, where maybe a brickwork, concrete, tiling you are doing. Construction with these materials adds too much weight to a building. So these type of non-combustible are very much required and gives weightage when we just talk about our rating things and fireproofing things. A protective layer of concrete over all surfaces of beam or over the steel bars is reinforced concrete has to be at least 2.5 inch, 6.4 centimeter thick to be effective. So when we talk about this layer of concrete over the surface beam, over the steel bars when we are doing concreting, RCC structures, that has to have a 6.4 centimeter thick, then only it can be effective in terms of our fire safety norms. Hollow clay tile used to cover beams and girders have to be at least 4-inch thick. Look, guys, you need to understand that when we are talking about different type of roofing systems, right? When we are talking about different types of flooring slabs and different type of frameworks, there are different type of requirements in terms of fire safety. Most buildings use lightweight fireproofing like gypsum, perlite, vermiculite mixed in plaster of 1 inch for such type of materials, right? So this is all description that this is basically required to be secured in as a fire safety material, that this much of thickness is actually required if you're using perlite, if you're using gypsum board. So you have to give this 2.5 centimeter 1 inch का thickness is basically required अगर आप 2 घंटे का time lag बताते हो, if you're giving that, if you're claiming that lag 2 hours time lag. Some recent buildings circulate water inside each column, protecting the structure against meltdown. So this is a very good and innovative approach these days, that circulating water inside column, which is basically protecting the structure's meltdown. So you can be very much innovative in terms of your fire safety norms. It's there are certain things which are coded in National Building Code, but again, you have to be very much efficient in designing and in giving different type of material solutions. In urban areas, building must also provide protection against fire. In neighborhood building through fireproof exterior walls, preferably windowless, since windows are fire opening. So once I gave you one example in just before slides. Key, when we there is a ratio of height and your fenestrations and ventilation also when we talk about this fire safety factor. So this they have already clearly mentioned that windowless, fireproof exterior walls, preferably windowless. So if you talk about exterior walls to be fireproof, they have to be windowless. Not windowless exactly. There are certain more terminologies about this also. There is some wire mesh glass, a glass which is usually available in the market. So fire has a property of going just high and high and high, right? So to control that, we have different type of typology of materials which can be incorporated into buildings, guys. So this is what you have to understand, that if my building is a long span building, so what I have to do with it? I have to give the fenestration also. How I'll deal this situation with, how I'll give the refugee area, how I will be designing my courtyards, how I will be giving the spaces for fire exits. That's completely up to a designer as an architect, because I cannot be the one who will be saying that, yes, guys, I cannot give so many windows and fenestration, so the game is over. This is not the part of a designer, right? So we need to understand that there are certain type of materials, need to study those materials, the performance analysis of the materials in terms of fire safety, and then we need to upgrade ourselves in our design. I hope you all are able to understand the things what I am trying to explain you. Om, can you please move on to the next? Yeah, we are here where these calcium silicate board are being displayed in front of you people. That one, the left side, it's gypsum board, and this another side is calcium silicate board. So, if you talk about this calcium silicate board, it's a very good sound insulator also. Okay, so because it's abrasion resistance, so it has a very good moisture resistive properties also, and fire resistive properties also. So whenever you will be finding a product, a particular type of product, searching a different type of product for your particular type of building, you will be able to understand, and you will be able to see a lot of resistive property in that particular type of thing, right? क्योंकि whenever you will be designing maybe a toilet, a washroom, so that has to be moisture resistant. The material has to be the moisture resistant also. The material has to be fire resistant also. So there are different performance in terms of resistivity, in terms of different resistivity. Understanding my point. Again, moving on to this gypsum board, which you say, and this being used for your partition board also. So this is the today's very much used product, which we says, and has a very good fire rating, uh, performance, a good analytical based performance, a good insulation, very much good acoustics, and a thermal insulating material which can be used in, winters, summers, both. So this is what the difference is in different type of materials. So again, when we were discussing about the previous one, it was just giving you the moisture free and the fire resistivity thing. Here we are getting the caustic proof, sound also, fire also. So when you will be checking, going out in the market, and when you will be checking the performance, you will always find a difference, that maybe the Gyprock will have a 50% of performance, and that's why being used so much, and being used worldwide in terms of insulation, also in terms of fire safety also, right? Next. Next, can we move on to next one? Okay, let me tell you one more thing about fire ratings for wood. So, as we were discussing about the rating systems now, so you people might know that there are different ratings. So, if we talk about our unprotected wood, it has typically a very low fire resistance. That means, I'll make you understand by some technical term, that is maybe 2-inch wood member may resist fire for 15 to 30 minutes. So nobody will be using this type of material. So this is said to be as an unprotected wood. तो मैं अपने घर में नहीं use करूंगी उस type की wood को, right? Understanding the performance analysis of that particular material is my task. That can only be incorporated when I will be understanding the percentage in terms of its this fire resistivity, right? When we talk about, let's say, it's heavy timber construction, so it can achieve a 2-hour resistivity time lag. Hmm. Why? Because of its mass, because it's heavy. So when you are given a solution, or maybe you are given a solution of this non-combustible also, which you say as brick, then if you talk about this performance analysis of brick, then you give the solutions, or we also advise you people, and that you have to give the thickness of the wall very much more as the usual thickness. 9 inches ki wall would not work. to protect you from fire or something like that, right? But now the question arises, these days 14 inches की wall बनाएगा कौन भाई? बिल्कुल सही बात है, कौन बनाएगा? Because we are short of spaces. So space नहीं है हमारे पास. So now these type of material has been incorporated कि 2 इंच के material से 2.5 inches के material से will be able to easily grab it out, and space requirement be will be able to combat with this situation. So the point is, you need to understand ki if the combustible material is basically can be done with this 14 inches wall or 24 inches wall, but right now at this present scenario, can we use that? We cannot. If we cannot use that, then we need to go to another type of solutions, and those solutions which we have already discussed, that the very much in type of things in the market used to be asbestos being depleted from the market just because of the research and the studies, and now we are using this gyprock as a basic material to which is very much fire resistive in terms of its resistance and performance analysis, right? Now if we look onto the slide, so the behavior of concrete during exposure to heat varies with the nature of coarse aggregate and its density and the quality of cement, which we have been studied being from last 20-30 minutes, that if the cement concrete is thin, then the fire resistivity will be, the performance will be different. If it's thick, will be different. Again, moving on to different typology of the project what we have taken. Aggregates expand on heating while ordinary cement shrinks on heating. So again, understanding the chemical composition of your material is important, and then using wisely that material into your building is basically an essential part of a designer. These two opposite actions may lead to spalling of the concrete surface. Aggregates obtained from igneous rocks containing higher calcareous content tend to crack more, while the aggregates like forming slag, cider, and bricks are better. So that's why these aggregates are considered to be better, where which are not getting very much which are basically forming a slag and containing higher calcareous content are basically try to crack more, and the things which are made up of bricks, cinder are more better in when we are talking about this content, this composition. Understand the composition of material, then put all the efforts in that material, and then use that material wisely into your design process. So concrete offers a much higher resistance. That's why all we know about concrete is that it's non-sustainable. It's not good. It's not maybe it gets heated very easily. So we all know this about RCC. But when we talk about strength, when we talk about fire safety things, we get to know that yes, it has some sort of benefits also. So reinforced concrete structures can withstand fire lasting for several hours with a temperature of 1000 degrees Celsius without serious damage. So when we talk about these two things, RCC buildings and the buildings which are created on hills on through wood, there is a lot difference. Again, there is a difference on the climatic conditions also, and the composition of the material which you use is differentiated. But as the session is towards this fire safety rules and towards the resistivity of the materials, so we would go on with the RCC things, right? Next, please. Now, moving on to the walls and columns. So you can see in the pictures also. So if you see this picture of clay tiles or terracotta, or if you see this gypsum plaster, or if you see this bricks or gypsum tiles, you see the enclosure towards these four walls, and then you see that there is a lining of these partition things. Maybe it's walls, or maybe if it is just the walls pay you are doing the terracotta tiling, so that is also one part of making your building fireproof, right? So masonry walls and columns should be made of thicker section so that these can resist fire for a longer duration of time and can also act as a barrier against spread of foe to the adjoining areas. So when we were talking in the last slide, the external finishes and the internal finishes has to be very much fireproof. So this comes to terracotta becomes to be the very much important part in terms of external finishes also. In case of solid load bearing walls, brick should be preferred to stone. So if we are taking the solid load bearing walls, why it is preferred? Because again it's a non-combustible material, but bricks we can use easily and they are preferred the most over the stones. If walls are to be made of stone, granite and limestone should be avoided. So it's a different thing. When we are casting a slab, has to be RCC. When we are doing walls, we have the brick as a material which can basically protect them from getting it destroyed or getting it dilapidated. In the case of buildings with frame structures, like RCC should be preferred to steel, right? Because again, we have studied in the earlier cases also, RCC is more fire resistive material in terms of its performance analysis of fire safety, right? So if steel is used for the frame structure, the steel structure component should be properly enclosed or embedded into concrete, terracotta, brick, gypsum, plaster board, and these type of illustrations being given, how the steel can be framed it out. Because directly we cannot open out steel as a framework. We need a certain type of coating on the steel also to make it fireproof. So these are the materials what being concrete, terracotta, brick, gypsum, plaster board, these type of things has to be coated over the same so that we can make it fireproof. All walls, whether load bearing or non-load bearing, should be plastered with fire resistant mortar. We have different type of categories of fire resistant mortar available in the market, which have different type of performances in terms of fire resistivity. We can go out and we can always understand the performance, and we can always incorporate these type of materials in our designs. Next. Okay, floors and roofs we have already discussed that. I've given you one example of flat slab and pitch roof. So this is very much basic that first of all RCC important, then when we go to the flat and pitch roof system, flat is which is taken as more importantly. जब हम trusses when we are dealing with taking aluminum steel as a framework, we need to coat it with different type of fire resistant materials, right? So flooring materials like concrete tiles, ceramic tiles, brick, etc. These are more suitable, and that's why they are termed to be as fire resistant. So you have also seen in the new age that stones being replaced on the floors also, tiles and terracotta being the more in market, right? Next. Hmm. Wall openings being discussed, but let's just go through this very quickly. From the point of view of fire spread, openings in the wall should be a bare minimum. From the point of, he has, it's been already mentioned that from the point of view of fire spread. Openings serve means of escape, hence these should be properly protected by suitable arrangement in case of fire. So it's very much required that the ratio should be maintained, the height of the building and whatever enclosure you are fixing in with the ventilation, that should be maintained. Doors and windows should be made of steel. Fire resistant doors can be obtained by fixing steel plates to both the sides of the door. So this is one suggestion, key it has to be of steel only, doors and windows. Wire glass panels are preferred for the windows. This I have given you one example that the fire has a tendency of just rising up and up and up, right? So what are these fire wire glass panels are? If you've seen wire mesh, अब उसी wire mesh में अगर एक glass लगा दूँ, fix in कर दूँ, it's just an example. If you'll see the wire glass panels out in the on YouTube or maybe on the Google, you will find out easily the images also. So what happens is कि if one piece of this cracks, this glass cracks, then the entire glass is not cracked. So अगर window पे we have used this type of wire glass panel, so what we can take it out that our fire, if there is a case of fire inside that enclosure, it will not just go rise to the building. It will take time, right? It will rise, but it will take time, and at that particular point of time, you will get time to get out of it, get escape out of it. This is what the process is. Rolling shutter doors should be used for garages, go down, shops, etc. Easy to, scroll up, down, and all that. In case of timber doors, minimum thickness of door leaf should be 4 centimeter, and that of door frame should be 8 to 10 centimeters. So this is what they're telling you about, that these are the precautions which we can take in terms of fire safety in our materials. All escape doors should be such as to provide free circulation to the person and passengers. Lobbies, corridors, stairs, etc. should be made of fireproofing material. So whatever we are using on the floor should be fireproof. That's all what we have studied, the material, tile, terracotta and all. Whatever the external finishes we are using, whatever framework we are using, we have to use check out the performance of that material in terms of fire safety. And then according to the national building codes, we have to give the space, because NBC has a standard, a given and a set standard for different type of corridors, for a one way, single way and a double way corridor, where we have to give a minimum dimension or a width for that particular type of corridor. It's been all coded, and you have to go through that, and according to that we have to design the spaces, right? Next. Okay, what do you understand by a strong room construction? I'll just give you in just a gist of it, that there are certain spaces in enclosure where we made that space for an escape from fire. We can, save ourselves from fire, because if we cannot easily get out of the building, we can just be there. So that areas will have a wall thickness, high wall thicknesses. The wall doors and ceiling of strong room are made of at least 30 centimeter thick cement concrete. If thin RCC walls are used, then should have a covering of bricks or terracotta, right? So these type of things we can do. That this is what our strong room is, the basically used for fire safety purpose only, and this type of material being incorporated here. Next. Yes. These are some design notes which has to be incorporated in our has been taken from the building codes only, and which need to be understand by us, that what type of minimum area is required for which type of enclosures. Like all buildings more than 7,000 cubic meters shall attach to access road or open area, and which has a minimum width of 12 meter. Road access width minimum you should have 6 meters. You all see in your, when you make your start doing your site plans, and you start doing your building plans and built environment and build forms, then you're always advised to give the 6 meter, 3 meter, 9 meter, this type of exit passages and exit road networks, right? So this is how they are designed. These are the specifically designed for fire safety rules, right? Maximum width of appliance is 2.5 meters and can withstand loads of fire engines. Maximum weight 26 tons. This is what width of appliance is, what you are given, and how much load they can withstand. Maximum gradient to access is 1:12. Minimum overhead clearance for access is 4 meter height. Fire appliances turn around requirement, T turn, shunt, or circle. So there are turn around requirements for appliances also, where which is being coded, and these requirements are very much important, has to be understood by us, that which shapes or requirement can achieve a good fire safety approach, right? Next. The spaces in the building are divided into smaller compartments for fire safety management reason, to limit the spread of fire. Because once you have a longer span, the fire will be spreaded more. Once you have a shorter span, the fire will have a limited area to get out of that. area to just move out of that area. That's why now you will have a question which you will say that if it will be a smaller area, then there'll be partitions. If there'll be partition, then how can you say that it will not move on to another section? It will move on to another section, but it will take time. And so we have to wisely check out our materials, that which type of combustible or non-combustible material we are using as a partition, or we are using in our slabs, or we are using in our entire framework. This is what we need to understand. A very simple logic. He Fire is catching in a broader area more. So we have to give it a solution of, limitize it into smaller areas. Yes, I understand that we require larger span areas also. For that, the building performance in terms of fire is different, right? This is just a thing that if we talk about spaces in context of fire, then the spaces in buildings are divided, should be divided into smaller compartments only, right? Restrict the movement of smoke, optimize evacuation routes during fire, accommodate different activities. So you have to be purposely group it out to enable each compartment having their own fire protection system. Now you have different fire alarms for different sections what you have created, different approaches or different materials being used in that particular type of compartment. Next. Now, okay, when we talk about this means of escape, so means of escape in my knowledge in terms of building comes out to be as the fire staircase what we provide, right? So an escape route should lead to a safety place. So it can be through a fire escape also. It can be a refugee area also. So without reliance on external assistance, the ultimate safety place is the open area outside the building, clear from the effect of fire. So you might have seen in the larger buildings, in the buildings which are vertically oriented, that the one refugee area at maybe the mezzanine floor, or maybe at the 30th, 20th, whatever people design, there is a particular height restriction also for this refugee area, which you can get it from codes. So where you can define that this is the open space where people can come, because some would, if it is a vertical zone, some would go out, some would not be able to go out trapped. Then there might have some refugee areas which should be open to sky. As we see the balconies, this is the shorter version. And if we talk about our refugee areas, the cantilevered refugee areas, they are the longer span versions, which are very much important in the vertical layouts, right? So in large complexes, it should be possible to reach a place of reasonable safety, such as protected staircase, corridor, where people can travel in relative safety to a final exit. Design of means of escape should take into account the building form, right? Activities inside the building. पता चला कि बिल्डिंग जो है वो बॉम्ब ब्लास्टिंग के लिए ही यूज हो रहा है. So you have to be very much specific and careful about designing and about the materials also, the chemical composition of that material, कि वो उससे the activities what are being performed inside, they are being matched through the materials what we are using or not, right? The likelihood of fire, the potential of fire spread through the buildings. These are the points, these are the means of escapes, and how we have to design means of escape in terms of this fire safety are listed down. Please, next. Next is our smoke lobbies. Access to staircase smoke lobby shall be by means of fire doors only. The width of smoke lobby shall be more than exit width. Smoke lobby shall be provided for exit staircase extended to basement. Till date, you people might be very much clear about these fire escapes. If I ask you कि यार मुझे बताओ कि fire escape should be how much area you need for that. I mean, longitudinally, vertically, what is that? So it'll be, you will all, everybody might have the answer that, ma'am, it could be maybe 22 to 30 meters ke span pe you have to give a fire escape. But there are certain terminologies related in terms of this fire safety rules, and that's what we are studying today, that we need to have these lobbies, and these smoke lobbies has their exit with more than that of the corridor which they are forming into with, right? Smoke lobby shall be naturally ventilated, minimum 1 square meter opening, or mechanically pressurized also, depending upon your designer, depending upon the architect, and how much accommodated area or people you are taking in that particular zone. So if it's a large scale project and the footfall is high, you need to understand according to that, and the lobby shall be basically has to be maintained according to that area. And if it's a small span area, then also, so these are basically found in restaurants. You can also see in the hotels these smoke lobbies, in the housing also, in the mixed use development also, right? Next. This is what all about is staircase, that all staircase enclosures shall be ventilated by having a minimum opening size of 1 square meters. In buildings not exceeding 3 stories above ground, staircase enclosures may be unventilated, provided that access to them to at all levels through ventilated lobbies. So you need to understand the intricacies of design, that whenever we are basically doing a sustainable practice, whenever we are doing or claiming fire resistive sort of things, or fire escape we are designing, or we are making a route towards it, so what all necessarily uh, approaches we can target it out. So I have already given you the way of materials. I have already discussed within these lobbies can be, and staircase can be, and then closures formation, and this formation of steel structures, and the formation of different type of brick structures also. So these all are just the limited amount of things which are relating to our fire escape things, fire safety rules, in terms of designing our platforms towards the built environment, right? Next, please. So this is all our codes, that corridor, passageway to an internal or external staircase, or to veranda or roof which have access to the street or to the roof of the building or a refugee area, may include horizontal exit leading to the adjoining building at same level. Continuously maintained free of all obstructions or impediments in case of use in an emergency, and shall provide continuous means of egress to exterior. So we have already might seen, you people have visited to malls, different types of commercial complexes. There you see out different types of exits. So you might see that the exit doors are smaller than the passage being they are narrowed towards, which is a wrong approach towards this fire safety rule. So you need to understand that whatever the passage width of the passage will be, the exit gate width has to be the same. This is the basic thing which you need to understand. Fire access staircase building having an area of more than 500 square meter per floor shall have a minimum of 2 staircases. So this is also coded, दैट अगर 500 मीटर स्क्वायर पर फ्लोर है तो आपको 2 स्टेयरकेस देना ही देना. Doorways shall open into an enclosed stairways or a horizontal exit of a corridor, providing a protected means of egress. Shall not be less than 1000 mm in width, except in assembly buildings. So when you talk about this width of the doors, you are very much aware about anthropometry, right? You are very much aware about the width of a door in context of ergonomics also. But we are not relating that thing to the fire safety norms. So fire safety norms also have some sort of equal balances. As we say, it should not be less than 1000 mm, which we usually not we are not doing, except in assembly buildings where it should not be less than 2000 mm in width. So when we are doing any maybe halls or some assembly areas, or where the number of people or mass has to get into the doorway, a lot of people has to come there, we need to think about it, and the width has to be go with the flow. shall not be less than 2000 in height, right? So can we move on to next? I think it's already 7:30. I hope you people are not bored. So let's just talk about the height also, which shall not be less than width of the exit doorways leading out from them, already discussed. So if you see in the right side picture, so the width of the corridor and the width of the doorway is exit doorway is as same. Height shall not be less than 2400 shall be adequately ventilated. So contradict कर गई बात, लेकिन contradict इसलिए नहीं की क्योंकि अगर आप smoke फ्री एरिया बनाना चाह रहे हो उसको एग्जिट डोर उधर देना चाह रहे हो, या फिर इफ यू आर टॉकिंग अबाउट जस्ट कॉरिडोर्स and exit doors, then it has to be properly adequately ventilated. And in fenestration and ventilation options, we always go with the ratio of height to that safety rules. Internal staircases shall be composed of non-combustible materials throughout, so that if because they have a high resistivity. नॉन कंबस्टिबल मटेरियल्स क्या है? आरसीसी हो गया, ब्रिक्स हो गए, these all. External walls of building shall constitute one of its sides, shall not be arranged around a lift shaft. Minimum flight width should be this much, maximum this much. Minimum tread should be riser and headroom all being given. So this is what it's just focused towards our fire safety rules, that these are the minimum standards or the maximum standards for designing a staircase, or maybe designing a exit width, or maybe designing the height of the particular enclosure. And it entirely depends upon the classification of building also. Okay, from one building to another building, it can be classified another approach. Like if I'm making a PVR, so my width of the door will be completely different, and my approach of designing will be completely different, because it's a single enclosure. I don't have compartments in it. A lot of compartments I don't have. It's a single enclosure. So my fire detection methods will be different, right? My smoke detection methods will be different, and my approach towards implanting the materials will be different, and depending upon the structure what you are basically developing. Next. So let's just talk about the staircase also. Staircase, you might all know. So the external staircase is desirable to be provided for high-rise building. So high-rise buildings, all these housing, all these mixed-use developments, all these things, we prefer this external staircase shall be kept in sound operable condition, directly connected to the ground. Entrance shall be separate and remote from the internal staircase. So there should be a difference in this thing also. We're talking about the high-rise structures, skyscrapers and all. No wall opening or window opens onto or close to the external stairs. Route to the external stairs shall be free of obstruction at all times. Shall be constructed of non-combustible materials, and any doorway leading to it shall have the required fire resistance. So you have to be very much clear in your mind that the material has to be non-combustible. In terms of fire escape, in terms of staircase, it's inside or the external one, it has to be non-combustible, right? Shall have a straight flight not less than 1250 wide width 250 treads and riser not more than 190 Number of risers shall be restricted to 15 per flight. So they are very much specific about this fire safety measurements and the fire safety, all the lengths and breadths of these fire escape routes. Handrails shall be of a height not less than 1000 and and not exceeding 1200 Provision of balusters with maximum gap of 150 So these all are the standards which we all study today. Next, please. This is what the horizontal exits, and they were talking about the vertical exit. So adequate, we should have an adequate headroom. You all might have seen the headroom in these vertical type of designed fire escapes. Unprotected steel frame will not be accepted as a means of escape. However, steel staircase in an enclosed fire rated compartment of 2 hour will be accepted as a means of escape. So when you were actually claiming yourself that you are the fire rated building. So you have to go with all these, parameters what we have seen today. So what they are discussing is that steel frame will not be accepted as a means of escape until or unless आप उसको claim नहीं करो कि 2 घंटे तक उस पे आग नहीं लगेगी, right? 2 घंटे तक की उसकी रेजिस्टिविटी है, तो उस enclosure को, उस कंपार्टमेंट को आपको फायर रेजिस्टिविटी 2 hours का देना पड़ेगा. This is what the safety rules say, and this is what how you can claim yourself to be as a fire rated building. Now, when we talk about our horizontal exit, the width of horizontal exit shall be same as that for the exit doorways. That means आपका horizontal exit has to be, again, if you're moving into a corridor, that has to be exited out with the same width. A horizontal exit shall be equipped with at least one fire smoke door of minimum 1 hour fire resistance of self-closing time. So it should have a minimum time lag of 1 hour so that people or maybe the extinguishers can work through the same, right? Where there is a difference in level between connected areas for horizontal exits, ramps not more than 1 in 10 slopes shall be provided. Steps shall not be used. So when we're talking about ramps, so this is the specification. Steps are not to be used. Doors and horizontal exits shall be operable at all times from both sides. So when we talk about our horizontal exits, the doors has to be properly exit doors. We are basically targeting our exit doors because obviously we have to move out of that area, we have to move out of the enclosure. The refugee area can be within the building also, or because sometimes the building is so much collapsible that in the collapsible situation that the refugee area doesn't work. So you need to have a very much strong and sound exit doorways. Next. Again, which it's all the codes that for floors above 24 meter and up to 39 meters, one refugee area on the floor immediately above 24 meters. तो अगर बिल्डिंग है मेरी 40, 50, 50, 60 फ्लोर्स की बिल्डिंग और मीटर्स की बिल्डिंग है, सो आई हैव टू बी वेरी मच क्लियर कि 8 फ्लोर्स के बाद ही आफ्टर 8 फ्लोर्स, 7 to 8 फ्लोर्स, आई एम प्रोवाइडिंग अ रेफ्यूजी एरिया. अब उस that area has to be very much ventilated, cantilevered होना चाहिए and O2S होना चाहिए. So you should be keeping this particular thing in your mind. And people who have already done these projects like housing or skyscrapers, they are very much well aware of these type of refugee areas. That if the building is very much high, so after 7 to 8 floors, we have to provide certain type of areas. For floors above 39 meters, one refugee area on the floor immediately above 39 meter, and so on after every 15 meters. So it's completely a cycle. Residential flats and multi-storied buildings with balcony need not be provided with refugee areas. Flats without balcony shall provide refuge area. So if we talk about big towers, twin tower, these type of skyscrapers, we require these refugee areas. If we are having proper ventilated balconies, this concept for fire escape, it's also a good connective concept. Fire towers, preferred and safest type of escape routes for storied buildings. In high-rise buildings with over 8 stories or 24 meter in height, at least one required means of egress shall preferably be a fire tower. So there should be, again, this is the limit of this thing, where we have to, in 24 meter area, after just 8 to 9 floors, we have to give that particular type of area that should be open to sky thing, where these fire towers are implanted and where you can basically save yourself, save the human life. Next. Next, please. So, as an architect, we are very much aware about this plan, which is basically showing you the, evacuation plan. So this is the way, and the corridors, you must see this evacuated area, and you can see the exits, the fire exits. There are two fire exits. So I'll tell you one thing that the concept of this 22 meters to 30 meters, what is this concept of fire escape is? So when you divide a building centrally, right? So when you are at the center of the building, so through that center, you will measure 22 meters to 30 meters depending upon your construction, depending upon the project you have taken. And then you will analyze the next fire route or fire escape route. This is what all this plan is all about, to make you understand that what can be the evacuation route, that from where you can be evacuated. So if you see this, this is a L-shaped plan, and you see at the left also there is one fire escape, and at the right also there is one fire escape, because it was required, because this is spreaded at the horizontal and vertical level on the x and y axis both. So it was required to give both sides this fire routes. Okay, I hope I am done with this thing. Anybody who's having any question regarding the session? No? Okay, let
I
us
think there are no questions, ma'am.
Okay, let us all commit to integrate these principles into our work, ensuring the spaces that we design prioritize life safety and resilience above all the factors what we all have studied. This is what my conclusion about the session.
Thank you, ma'am. So, as we conclude this webinar, I would extend my heartfelt gratitude to you. Thank you very much for conducting this session. And thank you all for participating. And we wish you luck for your submissions. Let's carry forward the knowledge into our professional practice and make the safety concerning in our designs. Have a wonderful evening and stay safe. Thank you, everyone.
Okay, thank you so much.